This is the PostLab analysis for the Beverage Density Lab. I'm going to walk you through PostLab questions numbers 1 through 5. The first PostLab question asks you to plot density versus concentration for the 5 reference solutions on a graph, which we call a calibration curve. The concentration is the independent variable, so that will be on the x-axis. That's your percent of sugar solutions. And the density is the dependent variable, which goes on the y-axis. Use a ruler to draw the best fit straight line through the data points, as is shown on the graph below. And also make sure that you use a ruler when making the axes. Label your axes and have your graph have a title. PostLab question number 2 says, use the graph to estimate the unknown sugar concentration in the first beverage. To do this, locate the point on the y-axis that corresponds to the density value of the beverage. For my example here, I'm going to use 1.06 grams per milliliter as the density that I calculated from my data for the lemon lime soda. You then follow that point on the y-axis across horizontally to where it meets the best fit straight line through the data. Use a ruler to do this. Now read down vertically from this point on the best fit line to the x-axis. The point where this vertical line meets the x-axis equals the percent concentration of sugar in the beverage solution. So in this particular case, we have a percentage sugar of about 15.5%. You can indicate that percentage on the graph, because then what you'll do is repeat this for your black cherry soda as well. So use a different color or a different type of style of line in order to do your percent for the black cherry. Then record those percentage values in your data table that you constructed for the pre-lab. That's PostLab questions 1, 2, and 3. PostLab question number 4 says, calculate the actual or accepted value of the sugar concentration in weight percent for each beverage using the nutrition label information and the measured density value. There's a hint to see pre-lab question number 3 how to do this. It's a 2-step problem. First, you need to use density to convert the 355 milliliter serving size to grams. Then calculate the percent sugar in the beverage. I've started the setup for the first part of this calculation here. You take the 355 milliliters per serving and then the density that you calculated from your experiment in the next step in order to get to the number of grams in the serving. That gives us a mass of 376.3 grams of lemon lime soda per serving. Then what you do is you take that mass and you use the nutrition label information to figure out how many grams of sugar there are per serving. According to the nutrition label, there's 37 grams of sugar in 1 serving of lemon lime soda. So I took 37 grams of sugar and divided that by the mass of 1 serving. Multiply that by 100% to get percentage of sugar, and you come out to a value of 9.83%. We then have to look at significant figures for this, so we go back to the original calculations that we started with. So we look at the first part of this problem, which was the division here. And in this case, we had 355 milliliters, which has 3 sig figs per serving, 1.06 grams per milliliter, that has a density, that's 3 significant figures. So far our final answer could be reported to 3 sig figs. However, if we look at the information from the nutrition label here, we have 2 sig figs with the 37 grams of sugar, and we're dividing. So in the end, we can only have 2 sig figs in our answer. So in this case, the percentage of sugar that's accepted for this soda is 9.8%. You'll repeat this process for the black cherry as well, and the black cherry number to use for the grams of sugar instead of 37 will be 44 grams of sugar for the black cherry, and the density of the black cherry will probably not be this 1.06 grams per mil, but it will probably be something else. So when you do the black cherry, you'll have to use the black cherry density instead of the lemon lime density. PostLab question number 5 asks you to calculate the percent error. The equation for percent error is below, and what you'll be using for your measured value is the percent that you read from the graph. The accepted value will be the percent you just figured out in PostLab question 4 for what was on the nutrition label. I've calculated the percent error of the lemon lime data here. We had 15.5% error, or not error, 15.5% sugar in the graph reading, and then from the label we had 9.8%. So I showed those values here. So you have measured by accepted over accepted times 100. To figure out how many sig figs to report your answer to, you have to go back and see what math you did. The first thing you did in this calculation was a subtraction. So the difference between these two numbers is 5.3 with the proper number of sig figs. So in essence, what you're doing is taking 5.3 divided by 9.8 times 100. Since 5.3 and 9.8 both only have sig figs, your answer can only be reported to 2 sig figs. So we have a percent error of 58%. And you repeat this for the black cherry. The last part of your lab report is the suggested improvements and conclusion section. Make sure that the suggested improvements, you start with 2 ways that this experiment could be improved are, and you use the third person voice, so avoid the words I and we. And in the conclusion, start with, in this lab it was learned that, and have it reflect the purpose. That's it.